what is the answer to this? Huh? Okay, so let's consider. I'm going to list out a bunch of multiples of pi over 3. Okay, Dallas? So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 6 pi over 3. You got the idea, right? And we could just keep going down the line. I would actually go 0 pi over 3, just to keep it going this way, and negative pi over 3, keeping it going that way. So that would be all the multiples of pi over 3. So here's 1 pi over 3, but here's this is pi over 2. 3 pi over 3 would be, I don't have this, this is not to scale, obviously. Sorry about that. But what is 3 pi over 3? Pi. What is it? What is the cos of pi? The cos of pi is here's pi. The cos of pi is -1. Okay. So this one we'd have to throw out. What about 2 pi over 3? Now, I have this better to scale now. So pi over 3 is going to be more like up here. Look, and 2 pi over 3 is going to be like down here. So we have to throw this one out. And 6 pi over 3, we got to... Okay, so let's see what happens if I go pi over 3. So you're thinking now, Dallas, right? Pi over 3. And then if I add pi to that, plus pi. Let's see. Here's pi over 3. So let's just make this, if this was pi over 3, if it's just pi, then it would be, we'll add 3 pi over 3. So that'd be 4 pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 would be about right here. Okay, so you guys see what I'm saying, right? You have to kind of look at the graph, use your unit circle. Let's talk about how we would find all the values that make this true. Now we're all in agreement that pi over 3, well, you guys got that. We're all in agreement that pi over 3 is a good starting place. Are we all? Is everybody good with that? Now, something to consider would be the period of the cosine function. What's the period of the cosine function? 2 pi. So what if, so isn't it going to hit this same thing at half every 2 pi from here? So let's just consider this one right here. If I add 2 pi, oh, there it is again. And if I add 2 pi, oh, there it is again. And there it is again. So we could say pi over 3 plus 2 pi n. But what, we've left half of them out, right? We have not considered this negative pi over 3, which we said up here earlier.
Plus or minus 2 pi n?
But if n is a negative number.
Okay, so does this consider negative pi over 3?
No.
So if I take pi over 3 and subtract 2 pi, that's 6 pi over 3. That's going to give me negative 5 pi over 3. Is that the same as negative pi over 3? No. So we have 2 starting points. So to take it into account, we have to think a little bit deeper than we did when we were looking at asymptotes. We have to consider, because the coast graph hits it in two different quadrants. It hits that. It hits a half in quadrant 1. If you think about this, 0 to pi over 2 is quadrant 1. There's quadrant 1. And it hits it in quadrant 4. Right? And every 2 pi beyond those, or going back the other way. So it's pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n. That is our solution to our original equation. This was fun listening to your conversations and answering questions and stuff. So, if you use your inverse sine function, that gives you a starting point. Now, because if you do that, you would get x equals sine inverse of negative square root of 2 over 2. There are so many different ways to do this. You can use your unit circle, you can use your trig graphs, you can use a combination of those two things, or you could throw in a right triangle. There's lots of ways to do it, right? Mm-hmm. Now, I tend to use the trig graphs and triangles. So I would, and I also use the graph of a y equals sine of x instead of its inverse, because that's really what we're looking for, is all the values on the sine curve where this happens. Okay, so it goes like this, right? All right. Close enough. Now it's got to be a negative square root of 2 over 2. Now that happens, I see, so I don't even care precisely where they are here, but if I do a horizontal line, I'm going to get this. Okay? All those places continuing in both directions will give me all the places where that happens. Now Tristan back there, he was on a good roll back there. He was looking at his unit circle. And so on the unit circle, we have to look, now the sign, is this, on the unit circle, is this a y value or an x value? On the unit circle. It's a y value, right? So we're looking for y values that give us negative square root of 2 over 2. So if I go down on the y-axis, negative square root of 2 over 2, it's going to be like somewhere down in here, right? So that's going to happen, and we all should know already that that is going to give us one of the multiples of pi over 4 or 45 degrees, okay? So this is where that happens. This is where that happens. This is where those y values are negative square root of 2 over 2. Okay, you guys tracking with that? So what is this angle? You could call it negative pi over 4, couldn't you? Okay, so x could be negative pi over 4, or what did somebody say? 7 pi over 4. So here's what my job is checking to see if your starting point is actually a good starting point. If you have this or this, those are both correct, because negative pi over 4 is here, but if I go 100 or 2 pi away from it, I get it 7 pi over 4. Okay? So either one of these, they're actually the same starting point. Right? Okay, so and I can add and then it's every 2 pi. Okay? So just so that you know, if you had this as your answer, you only considered half of them already. These are two different things, because negative pi over 4 is right here, but 7 pi over 4 is right there. They terminate in the same place. So you either have to say this, or any starting point that's at the same place. Okay? Sam?
So on the test, I could put 15 pi over
I have to think about that.
Yeah, 'cause 16 pi over
Is
4
he right, you
Or
guys?
One less
Yeah.
than 16.
Oh, yeah, you could. So if you put 15 pi over 4 plus 2 pi n as your starting point, that's fine too.
Or negative
That already
7
takes into
pi over
account those
4.
two. Okay, so this one, so I'm just gonna stick with one.
That'd be pi over.
Now, if you put this, you are a groovy person, okay? I'm just gonna have one, so,
So that'd be 4 pi over 4 plus 1.
okay. Now,
You're going negative.
now we also have to consider this one. Now, or if you were actually thinking of it, so this was in quadrant 4 right here. This is quadrant 3. So you could, what would that one be?
Negative pi over 4.
Pi,
Or, sorry, 5 pi over 4.
Okay, you could say it's 5 pi over 4 plus 2 pi n.
Or negative.
Or
3
you
pi.
could say x equals negative 3 pi over 4 plus 2 pi n. No, just one of these, not both of them. But if you did this one and this one, or this one and this one, or that one and this one, or that one and this one, your answers are all correct. Okay? And so my job when I'm correcting your test is to see if you have the right starting point and adding the right amount. If you have a right starting point and adding the right amount. That's my job. Your job is to come up with those. Okay? But now this accounts for all of them. Jules?
Is it always, well, it's not always, but like, is it usually gonna be 2 pi n? Like added?
What would it be 2 pi n for? Anybody in here that knows? What would it be 2 pi n for? Carolyn?
Sine, cosine,
Sine, cosine,
cosecant, and secant.
secant, and cosecant, and why, Carolyn?
Tangent, cotangent, have a period of pi.
Correct. Okay, and that's actually, in general, I'm going to say her answer is correct. There is situations where it's not correct, but we'll get that in a little bit, okay? Is everybody groovy? Okay.